This is Algebra Lesson 8.4, Multiplication and Exponents. So we have two exponent properties, I guess three rules though. The first is the multiplication property. Given the same base for any non-zero value b, and given two different integers, or any integers really, for powers m and n, to simplify that expression, the base would stay the same, and the powers get added together, m plus n. Now we have two different power rules for any non-zero values of bases a and b, and any integer exponent values of m and n. If I have a power raised to another power, I will multiply those together. And if I have a product being raised to a power, a times b to the power of n, I need to essentially distribute that power. That power is going to go to both pieces. For my examples, I am going to write these both in expanded form and then in exponential form. The first example, 3 to the 4th times 3 to the 2nd. Expanded, 3 to the 4th means 3 times 3 times 3 times 3, and 3 to the 2nd means 3 times 3. If I multiply this all together, since multiplication is commutative, I actually have 6 3's. So my expanded form is 3, 3, 3, 3 times 3, 3, and then exponentially, I used my rule up here. If I just have added the 4 and the 2 together, I get that there are 6 3's altogether. So we'll do the same thing here. I have 3 x's, and then I have 5 x's. Altogether, I have 8 x's. I have 4 to the 5th raised to the 2nd. So that is going to be my power of a power rule. In expanded form, I have 1, 2, 3, 4, 5 4's, and then I have another group of 5 4's. I have two groups of 5 4's. So in exponential form then, I have 10 4's. The quicker way to arrive at that answer again is just multiply 5 times 2, and I have my 10 4's. My next example is x to the 3 to the 4. Same rule. I have 3 groups, and then I have 3 groups, and then I have 3, and then I have 3. I have 4 groups of 3. I have 12 x's altogether. And on to my last rule. I have xy, and then I have another xy, and then I have another xy. This is expanded form of xy to the 3rd. Now if I look all together, I actually have 1, 2, 3 x's. It doesn't really matter what order they go in. I can rearrange them. I can group the x's together, and then I have 1, 2, 3 y's. I can rearrange and group all my y's. So essentially what I did is just put the 3 on everything in the parentheses. Now my last example is a conglomerate. I don't know, is that the right word? I'm going to put a lot of these rules together. I'm going to start, I guess I'll expand it out. I have 4, and then 3 x's, and then 4 y's. I have a 3, an x, and then 4 y's. And then I have a second group of the same thing. And now we're going to put everything together. When I'm writing these in exponential form, I want to group all of my pieces. The instructions aren't super clear, so I'm going to do it this way. I have a 4. I have 2 3's. I have 1, 2, 3, 4, 5 x's, and I have 4 8 12y's. Conventionally, we would put these two together if the instructions told us to put it in the form a, x, n, y, m. Doesn't really say, but I will in this case. So that is 36, because 4 times 3 to the power of 2 is 36, and I'll leave my x and my y. I would, depending on the instructions, you know, either one of them could be correct. Okay, so that is it for the notes. Pay attention to if the exercises say to give both the expanded form, or if you can just do the exponential form for some of them. Okay, that is it. Good luck. Let me know if you need any assistance.